This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Gavin Henry, and today my guests are Shannon Selbert and Parker Selbert. Shannon is an inspiring polyglot programmer, product manager, and contract law enthusiast. After a stint doing technical training for the government, her entrepreneurial spirit led her to co-found Soren in 2008, where she consulted for over a decade before transitioning to the development of Oban Pro. Parker is a developer with a passion for building things both virtual and physical. He is the creator of Oban Background Job Framework, chief architect at dscout, and partners with his wife Shannon at Soren, building Oban Web and Oban Pro. Shannon and Parker, welcome to Software Engineering Radio. Is there anything I missed in your bios that you'd like to add?
No, nothing from me. Those are pretty robust bios.
It was a fabulous introduction.
Thank you. Did I get the name of your company correct?
One of the few people who has. You did.
Excellent. So the goals for the show, we're going to explore the terms reliability, consistency, and observability in relation to job processing, and understand how Oban with Elixir and Postgres and or SQLite deliver those features. So let's get cracking. We're going to do a brief overview to start with of what robust job processing is. And then in my usual format, we're going to do about 10 minutes on 5 different topics to understand how you guys deliver this with your product. Those topics are going to be Oban, reliability, consistency, observability, and databases, which in this case are Postgres and SQLite. So let's dig in. What do we mean by robust job processing, the big one?
So robust really means batteries included. It means that when you install Oban as a package, it should be featureful, ready to go with a minimal amount of extra configuration and have tools that you normally would have to add on, like CRON or scheduled jobs or lots of other little bits. So when we say robust job processing, it's really just about how featureful it is.
Okay, thank you. Shannon, anything to add to that?
No, that was it. I probably would have added uniqueness to it, but I think his explanation was splendid.
And a job, what do we mean by a job? Is that a discrete bit of work or, part of a bigger workflow or?
Well, a job in Oban wraps up basically the queue name, the worker argument states into a serializable struct. That's what I would say a job is.
Yeah, the goal is always for some side effect. It's to have some bit of work that has a side effect. It's not a pure functional kind of thing. It's a side effect like sending an email or processing a video or generating an export or something. When we say a job, it wraps up all the arguments and data necessary to perform that piece of work.
And this would typically be something you don't want to sit and wait for as a user of a product, or maybe Oban's just used completely standalone to do something.
People definitely use it as a standalone kind of tool, but I think more often it's part of something that's like an online system, a web Phoenix application or something that's serving up traffic and then has to do other bits of work in the background.
Okay. And we use the term robust because we know it's going to get it done. Is that right?
Yeah, I'll subscribe to that.
We like the term.
Yeah. So once it's all in the system, we can chill out and relax. We know that it's going to perform it, or, if we set it up, it'll let us know why it hasn't.
Correct.
Monitoring or whatever we've chosen to suit. Okay. So that was a good, completely high level overview of what robust job processing is.
I guess we could go into the state machine, I suppose, the job state machine for it, but
I think we'll get there.
We'll get there. Okay.
Yeah, but I think we'll touch on that in the next section and then revisit in each of the other ones to back up our selection of words here: reliability, consistency. Cool. So, Oban, what is it? Who would like to go first?
I always start with the word robust, and we've just defined robust. So
well, let's have another go.
So it's a background job processor. It's something that manages jobs in a persistent way.
I think there's one critical word here, though, is that it's specifically for Elixir.
That's right.
The language Elixir.
Let's get on to the brief history of Oban. First of all, because I live in Scotland, there's a beautiful place called Oban. So is there any relation to that?
There is. I'd love to tell you that our children were conceived there or there was some fantastical story woven around it. But for us, we love the town of Oban. We love the little bay.
And you could say that there is another Elixir that is exported from Oban,
that
which
Parker,
is very inspirational.
That he finds very inspirational.
Oh, that's cool. Well, I guess right then. There's not many.
Yeah, it's a beautiful place. It's a beautiful word, nice and short, and just has some good aesthetics to it.
Some symmetry to it.
Great symmetry.
Cool. And when did you release it? Give us the history.
I think we just hit the 5-year.
We hit the 5-year anniversary
about a month ago. So about 5 years
in February.
Ago. Yeah. So 5 years ago is when it was first released.
Have you got any major lessons learned since that first release?
Oh.
Yes, we absolutely have some lessons learned.
That's a difficult one to prune down.
I think we have separate lessons. I would say my primary lesson, we didn't know how successful it was going to be from the offset, but wanted a way to be able to focus on it and give it time and not have it feel like a chore or a burden. So we always wanted to add some monetization around it. So the lesson is, if you do plan on monetizing something in an open core kind of model like we do, that you should be very selective about the features that you put in, because once you put something in there, it never comes out. And of course, you're always going to have this revisionist kind of plan of like, well, I shouldn't have done that. We should have done that. I think it's worked out, but I think if I were to give advice to anybody else who's starting something, I would say start with the bare bones and go from there, and don't just keep plowing features into something.
Yeah, so just to recap, Oban is an open source project that is that is for the Elixir language. It's a robust job processing engine and more, but there is a commercial aspect to that open source project as well. Could you just tell us about that?
Yeah, we probably shouldn't have backed into that. So there is the open source version, which is just called Oban. And then we have 2 commercial offerings that are built on top of that. One is Oban Web, which is for observing and interacting with the jobs. Another is Oban Pro, and that expands on Oban's functionality and adds a lot of more advanced or complex functionality that businesses need as they grow.
And just to be clear, Oban Web is just exposing what's already there, so it doesn't stop you for orchestrating your own telemetry interface or, job processing interface.
Right. Absolutely not.
Is there a typical use case or a really one that stands out that you use to show off Oban that you could tell us about?
We don't, when it comes to specific use cases, especially for people who reach out to us and trust us, a lot of those use cases are confidential. So I would say fintech, energy, a lot of use there. The Norwegian Postal Service depends on Oban.
That's a highlight.
It's a highlight. That was a great day.
I think a really common use case, like the hello world of Oban, is sending emails in the background. Because it's something that you want to make sure happens, but it's also something that can be kind of slow, or you want to schedule sometime in the future. And I think that's kind of the entry, the gateway into using Oban.
I agree.
Okay, can you back up that example with some sort of numerical data, throughput size, how many things can sit in a queue? Obviously, that'll be dependent on the receiving end of where you're sending email and things, but just to help the listeners understand the scale of Oban.
Well, we have cases of over 1 million jobs a minute, over 100 nodes, workflows over 1,000 jobs.
People processing 100 million jobs a day. So it scales pretty far. A lot of it comes down to the real limiting factor as far as performance tends to be what a job is doing. Because the whole point is that there's some sort of side effect, and you're going to have external resources there, whether that's a network or CPU or something like that. So usually the response time, and we just want to make sure that it has a minimal impact on the database, and that people can process things, and Oban is not a bottleneck or a source of contention for their system.
Do you have a problem since the start of Oban that you think back, well, the next thing that comes along, I know I've already solved this and it was really hard, so I've got that confidence? Was there a really hard nut to crack on the journey so far?
I don't think we've actually cracked the hardest problem.
That's what I was thinking too. Take
us through that hardest problem.
Yeah, so the hardest problem has been scaling in a sense, despite what I just said, because Oban runs in somebody else's application. And that's a lot of different somebody else's. We don't have any control over the hardware, the number of nodes, the number of queues they run, what their database version is.
How they deploy,
yeah. Because you don't have control over that. You have to build things out in sort of a lowest common denominator way, where you know there's going to be reasonable performance in any system. And that's something that we just kind of learn little lessons on and improve over time.
Why does it run in someone else's application, just so the listeners understand?
Because the jobs are somebody's own business logic that runs in their application. Because it's a package. It's not a standalone. It's not like a SaaS app where you send something off and it runs. Like, we're running the jobs for you.
It's integrated with a certain amount of autonomy.
Yeah.
Okay, I understand. It could be classed as a plugin, but it's much more than a plugin. But in similar other frameworks, whenever you have some type of asynchronous job you want to do, or that's slow, you'd reach for its robust job processing toolset, wouldn't you? And that's what this is for Elixir.
Yeah, it's an add-on package.
It's lightweight. Some say plugin, some say dependency.
Do you have a best fit for it, or is that not a thing?
I think it broadly fits into any Elixir application, personally.
I don't know that it's pretty broadly used. And some of the examples that Shannon gave before about different industries, we know of it like it's part of the boilerplate that people use when they start a new Elixir application, all the way up to some of the mega companies in the Elixir space using it. So I don't know if there's a best fit in scale or even category or industry.
Yeah, well, I'll give you two examples of where I use it personally. I've got an open source project that uses it to deliver analytic reports, much like plausible.io, another open source project, use it. And then in my day job, we run probably a couple hundred jobs a day through it. And how I architected that is any external call to a third-party API is a job and a worker. So we have a situation where we speak to an API to build a customer's account, all the features around that, the different applications in that API that need to receive a post, basically, with a blob of JSON. And every one of those is a worker job. And once it's finished, it pops another job in the queue. So it's all daisy chained. And that works really well. When there's an outage on the API or there's a error 500, it will bail out, sit there. And I've had a job sit for maybe a week before anyone's noticed that it's not doing what it should be, and they just click retry. And I personally love it, but anyway, just wanted to add that other use case.
That's brilliant. That's such a fabulous example of the persistence.
Yeah, and just how you can retry a job and it's got all the metadata and everything. I just love it. That's why I got you guys on. Right, so I think we've done a fairly good job of discussing what Oban is. So we'll drill into the different terminology before we move into the next sections. So let's envisage with the use case you've both explained. We've got a marketing campaign, for example. We've got 1 million emails to send out, but somebody needs to sit in front of the web browser and click schedule that job. So take us through that, and then what parts of, once that job's in the queue, what's been submitted with it, for example, what gets looked up. How does Oban get told about the job? How does it indicate that it's worked? If it doesn't work, what does it do from that point? Would that be a good use case to explore?
So we said before that jobs are data. So there are different components to this, which is there's a worker, which is a module, an Elixir module that has a defined interface. And then there are queues, which it's a name to group workers. or jobs. And then there's the job, and the job is a data. So it's a bundle of the arguments, the worker, the queue, and some other metadata that you alluded to before. And the way that the state machine works is you insert this into the database. I don't know if we've mentioned persistence before, but the persistence here is a relational database. So SQL, typically Postgres. And so you insert that job into Postgres, and it has either a scheduled state or an available state. And Oban will then notify all of the running instances, all the running nodes. So nodes are Erlang parlance for different instances. It could be different servers. They don't have to be, because it just horizontally will just transparently scale out. But it notifies the various queues. If a node happens to be running a queue that matches the job that was just inserted, it's notified about it. It will then go fetch that from the database, mark it that it's executing now, do whatever work it has to do, and then based on whether that fails, succeeds, is manually canceled, something like that, it then writes it back into the database with this final state. And there are some other nuances there, like if it failed, then it will go back to a retriable state. We'll schedule it, and there's some back off and things that happen there. But that's roughly the process that happens. Is that what you meant by state machine?
That's exactly what I meant. Aside from the acking in the middle and perhaps the default amount of retries. But in his example, I think that's great.
Yeah, the state machine is the status of the job.
Yes.
As it were.
Yeah.
And you can prioritize your jobs as well. That's probably something that, there's a lot of little intrinsic things you can do within that, but I would say priority is great.
Right. As far as the extra metadata.
Right.
Yeah.
For your metadata that he was mentioning.
How does the database tell the other workers that there's something ready to do? Is that something they always look for and pull Postgres, or how does that bit work?
This has evolved over time. Initially, we had a trigger function in Postgres that would then send a message using Postgres PubSub. We're going to say PubSub a lot as we keep talking, I think. It's really central to the way that Oban does stuff.
It could be a drinking game.
Yes, PubSub drinking game.
I think it could.
And it would push a notification out, and then that's what will be picked up by all the nodes. It'll be broadcast to the nodes, and if it matches a queue, then the queue knows to fetch. That doesn't work for scheduled jobs, though, because you could insert something now, but it's scheduled to run a minute from now or an hour from now, and so you can't broadcast something. So then queues would pull every 1 second to go look for jobs. Well, we mentioned before that there are some companies that run hundreds of queues, or they run hundreds of nodes, and you can't have all of those polling. That's just way too much load on the database, especially for most of the time there's nothing there. Most queues aren't saturated all the time. So it evolved into where every node has a central process, which we call a stager. And the stager, there's an elected leader among the whole cluster. So only one stager runs. And then the stager polls, and it checks for available queues. And then it broadcasts to the relevant queues. You have available jobs, and then only those go and run. And by doing this, we reduced the number of queries every minute by a factor of, 60 times however many nodes you have. So it was very significant.
So Parker, could you just take us through what a stager is again?
Stager is our term for, it's a gen server, which is a Erlang and Elixir concept of a standalone process that can send messages to itself, receive messages, manage some bit of state, and operate autonomously. And so in the context of Oban, the stager is a single process across the whole cluster, and it uses a leadership mechanism to figure out which one is should be the leader stager. And it's the thing that pulls the database every second to look for scheduled jobs and available jobs. And then it notifies queues all across the cluster that they have jobs to run. And by using this, you alleviate having every queue on every node have to pull, which dramatically reduces the number of transactions and queries every minute.
I understand. Yeah, just to close off this section before we move on to reliability, you mentioned that you can have scheduled jobs in the future, and that's something I do as well, where we have somebody initiates a job to go and build something against a third-party API. So it starts the first worker, completes, inserts the next one, etc. So there's a sort of cascade daisy chain. But we also have something that runs every 3 hours to go and pull another API to check for status updates on support tickets, and update the database. So I just thought it'd be a good example to explain for the listeners. Okay, so I think we've done a good sort of mid-level overview of all the bits. We'll discuss more of those in the next sections. But now I'd like to talk about reliability. You've spoken about the stager process or node. Would we like to take a second just to define reliability in relation to Oban? What is reliability?
So in terms of reliability, I think that with Oban using at least one semantics, that means that a job is guaranteed to run at least once. And if it runs and it fails, there's a safeguard there to bring the job back and make it run again, much like you stated in your example of how you use Oban.
Part of the way Oban is built that's different from other systems, or at least previous systems, because I know some job processors in other languages have picked this up now, is that jobs aren't deleted from the queue the moment that they run. They stay in the queue and their state is transitioned, so you can go look at it, which I think we'll talk about later. But because of that, you're guaranteed that if something happens, like if somebody trips over the power, if the node goes down or something, that the job's not lost. So you have this guarantee that within the transactional database, you're not going to lose your work.
Which particular bits of Oban Elixir do you use for this type of feature?
All of them. All of them. The supervision trees, registry, heavily, process monitors, dynamic supervisors, process groups.
Yeah, it's, I think pretty much the whole standard library is in there. And then some things that aren't even, that are deeper, Erlang OTP concepts are in there too. It all comes to play. It's just the way that you build a system that can save itself, rescue itself, monitor itself. It's the way that you build stuff in Erlang and OTP.
So when you state that it will definitely run once, the whole of the Beam in Elixir language has a massive part in that.
I think so. I think you can't downplay the role of Postgres in the whole thing. That's really important as well. But the Beam has the fact that you don't have threads in separate processes. Like if you want to scale up, if you just can't manage to process things, you're not going to have a thread crash or a process crash and then drop all those jobs. Because in the Beam, you have different separate processes, and all of those processes are supervised. And so you know when they go down, and the supervisors are then supervised. And so you know this queue is having a problem. Shut down that queue. It's got bad state. Start it back up. All those things just make sure that it keeps running smoothly without taking down whole wings of your application.
So I'll keep going back to this email example. Say we've got 1 million emails scheduled to run. Would the design part in there be there's a job per email to send, or is there a database table with 1,000 emails in it, or a CSV file to loop through and then send? How deep do you break apart that email job? So say, for example, there was a power outage or something. You don't want to send the first 500,000 emails again.
People do this in different ways, depending on how many things you really want to insert. It could be that you bundle a bunch of emails, say you chunk it, and so that every email has 10 or 100 or something like that. And then you're guaranteed that once that batch of 10 runs, that they're not going to resend. But there's always the downside that if you don't do them all individually, you could get to the 10th one and have the previous 9 double send. So the way most people do this is a single job per email. It's not always convenient to put 1 million emails in, but it is the most reliable way to do it.
And there's no problem with that type of use case because you've already explained that. Okay. Which part of a platform or system are not reliable that Oban helps solve?
I don't want to cast dispersions on anyone, but I would say the application around Oban is probably the most unreliable part that's not reliable.
That's true. That tends to be one of the biggest problems, is that it's sharing.
It's sharing the ecto pool with the host.
Yeah. It's sharing the ecto pool and it's sharing the database. And if the ecto pool is starved because other parts of the system are running, then it's going to look like Oban can't fetch jobs or it can't act jobs or the things that it needs to do to run, when really it's kind of a shared resource problem.
I mean, Ecto is the, you'd probably call it an ORM when you object relationship.
Yeah. It's the database adapter thing in Elixir. Yeah,
and out of the box, it has, for want of a better term, a thread pool, 10 connections or something that you need to make sure you manage if Oban are going to take a few of those.
Yeah, and so Oban shares those. Each Oban instance holds, it depends on what you use for PubSub, but it might hold one extra connection to the database for each node. But you don't have to use that, but it will always have to use the Ecto pool or an Ecto pool of some kind just to have those connections to do queries and do the things it needs to do.
And say, for example, the application is rock solid. The application developer is very proud of what they've built, and it's nothing to do with them. But they've not spent a lot of time on the Postgres side, and that goes down. If you restore from backup and the jobs are in the worker tables, they'll just get picked up again and looked at. Would that be right?
That's right.
So it's just your standard database management type thing, and ops.
Which is also another benefit, is one of the many benefits of using Postgres as your queue instead of something else that maybe doesn't have backups. Like if you're using RabbitMQ or Redis or something where you don't have the same cadence of backups or a follower or something like that, so that you're guaranteed that you don't lose data if something crashes or the hard drive goes or whatever it is.
And the architecture that you use for the database is completely up to you. You could have a write-only cluster where the jobs get inserted and a read-only cluster where they get pulled, that type of thing.
No, it has to have read-write access, because pulling a job is still an update action because you're transitioning the state. So it will write something. What was the other?
Oh yeah, because it's treating the whole thing as a state machine. You need to acknowledge the fact that you've queried it, and that increments something like this job has been retried 8 times out of a max of 20, whatever you set on the queue.
Mm-hmm.
Excellent. I think I'm a bit weird and love talking about retry algorithms. I did once try to get someone else on the show who invented the Ethernet retry algorithm, but it didn't work out. So if you could tell me what you reached for yours, that'd be great.
So is that Nagel's algorithm? Is that no, Ethernet's not the same as TCP, right?
The Ethernet's the whole frame, I think, of the packet. TCP's a bit of it. Anyway, yeah, so if a job fails, what have you used to look at that and back it off and all those types of things?
For us, it's the exponential back off with jitter. So do we have different algorithms in different spots?
Yeah.
I think that's the one that, for reliability especially, we depend on. So there's some element of randomization. So if there are 10 jobs and there's contention on that resource and they're rescheduled at the same time, then you're going to have that same contention. So using that algorithm with jitter inserts that random number within the calculated future attempts and breaks that up.
Yeah, I've seen that myself. We had the scenario I explained where we speak to a third-party API to build various bits of a whole customer account. It was down or there was some issue, and I clicked the nice select all job tick box and just clicked retry them all. And we found some race conditions in the API basically that we were speaking to. It was provisioning things that didn't lock, so it looked as if there was 10 things available, and then 20 jobs came, and then when they all tried to take that resource and use it, it just didn't work. So it's good to use Oban to stress test third-party APIs.
Yeah.
It's very quick and it's very good.
The biggest place that backoff's really apparent is with job retries, but is used in lots of other places internally as well, because database queries fail. Like there's either pool contention or things are just slow or who knows what's happening. So we have little retries around a lot of other parts. But something important to note for jobs in particular is that you can customize the backoff too. So sometimes people use a fixed backoff. It's like it tries again 10 seconds later, or they have their own other algorithms. So that's kind of a pluggable thing that people can do.
That's good to know. Okay, I'm going to move us on to my next section called consistency. Someone like to have a go of defining consistency?
Consistency. Yeah, this I think is actually a little bit harder than the other one.
I tend to use persistence in my definition of consistency, which is probably not ideal.
Well, for the listeners, how I developed this show is I took your strap line and then broke it up. So this is one of the key terms in your strap line.
Yes. I'm well aware that it is our verbiage and our fault.
The goal, just to make us really regret those particular word choices.
Which we kicked around for quite a while.
Yeah. So there are, I guess we could point out a few things. The fact that jobs are only going to run on a single node. Just the tooling that's used, the queries that are used mean that there's no chance you're going to have something run double and not record that it has 2 attempts. So if you say the max attempts are 2, you're not going to have it run 3 times. You're not going to have the same job run on 2 different nodes at the same time. These things are prohibited by the queries that we use and the way that things are structured. And then another big one is around leadership. And so Oban is a hybrid, distributed, and centralized application. So because we're relying on a database, there's this element of centralization. But because you have multiple nodes and they're all acting autonomously, there is a distributed system that's behind it. That means to make sure that things are, say, cron jobs are only inserted once, or there's only one node that's going to clean up old jobs, or things like that. We have a single leader, and the elected leader is the one that does it. We don't have to use a distributed consensus algorithm like Raft or something to do it because we have centralized leadership.
And if that leader goes down, that's taken care of by the Elixir tools and what the Beam can do.
Yeah, and the leaders always go down because people deploy new applications. And so if you're doing a blue-green kind of thing, your old leader is going to shut down and the new one's going to take it, going to come up.
Yeah, that's what we do when we deploy incremental changes on this application I explained. There's 2 nodes. They will canary deploy. So one will go down and upgrade. If the upgrade doesn't work, it'll try again, etc. But just to back up your consistency explanation there in this application that I was doing, you'd be sat in front of it and you'd be uploading a PDF. So that PDF needed to get onto a support ticket. So initially it took quite a while for that PDF to upload because it was big. So I thought, this is perfect for Oban. I'll just have it as a job, gets inserted into the queue. The PDF is saved on the file system of the container, so it'll go and fetch it. But then it wasn't consistent because depending on what node you hit when you were uploading the PDF, it would only be on the file system of that Docker container. So if it so happened that the node that ran the job to grab the PDF and upload it hit the right container to look at the temporary storage, it would work. But then 2 seconds later, another job would come along because it couldn't find it, because it was connecting to a different node. So I had to completely change it to have shared storage. So that use case of an asynchronous job to keep consistent failed because the file wasn't in a consistent place for Oban to find it, to upload it to the ticket system. So yeah, you kind of reach with these great tools and then you think, I've just messed up because I've not designed it right,
Yeah, that's one of the downsides of always being in a distributed setup. I mean, it scales horizontally in a completely transparent way, no matter how many nodes you throw at it. But that also means that it's going to change some of your design decisions about where you store these resources.
Right.
Yeah, it took me a while to actually realize that the workers were individual on my setup anyway. And it was trying to find this folder that didn't exist in one place, but it did in the other. So it didn't take long to sort it, but it is a different way to design things for sure. So how does Oban provide this consistency with regards to the new leaders? If, like you say, when you're doing new deployments, things get stopped and started.
So we have kind of 2 pluggable mechanisms. One uses distributed Erlang as a cluster, which is not a very popular mechanism to do it.
No, a shocking number of Elixir applications don't use a cluster. They centralize through Redis.
Or Postgres or something like that.
Yeah, something.
So I think when we polled, it was at least 40% of even the people that we know that use Oban, they don't have a cluster. So that means that their individual nodes can't talk directly to each other. They have to go through something that's kind of centralized. So we use a centralized leader, as I mentioned before, which means that there's a table and whatever the leader happens to be, every node sort of races to take ownership of a row in that table. And eventually that row expires. And when it expires, another node can insert its own, and then it becomes the leader. So all the other nodes can see whether they are the leader, who is the leader, and it's a pretty simple mechanism, but it's guaranteed to be consistent because there's just one central resource.
So that's kind of like mutex, shared mutex on a thread, wouldn't it be? If the leader grabs a row and manages to write and say that's mine, then everyone else comes along and sees that there isn't one available.
Yep.
That's cool. I'm one of those 40%. I run the nodes in the cluster. And that works really well because some of the telemetry interfaces, the Phoenix dashboard that shows you everything that's going on, that works nicely with a cluster, and you can do a drop down and see what every node's doing. So it's worth the extra effort, I would say.
I think that it's recommended. I've heard Parker recommend it, therefore I recommend it. So
especially for people that use web, Open Web, there's a package behind it, which is called OpenMet for metrics. And there are different queries that happen, like say counting jobs across queues and things like that are pretty slow. And we don't want every node that you have to do it. We want one node to do it, but you want that data to be available on any node, sort of like the situation you mentioned with the file upload. You don't want to randomly, like every time you connect, you're going to get a different web node, and the one that's the leader would have the counts, but the other one wouldn't. Since we don't want that, they have to broadcast information between each node. So they all have a kind of a consistent view of the stats and all the metrics that we display, but you don't want to duplicate the work behind getting that.
And just to close off this consistency section, so we've got the example you said where they tried to insert a record in the database and to let everyone else know that that leader is in charge. And then it's guaranteed for a job to at least run once, and then it will be retried. So you know that it's going to be consistent. Is that correct? Did I understand that right?
Yes. There's also partially just the way that you query Postgres and the way that we move things between states. That adds a little bit extra. And then hacking and retry, like those are all parts of just maintaining a consistent view of the data as well.
Is that more than like your standard transaction type thing? Or
it is a little bit more than the standard transaction. There's something that is part of a select query in Postgres. This is very widely used for any system that does Postgres as a queue, and it's called skip locked. And it's a way to have different processes or different connections query for the same data and fetch things that are not actively being fetched by another connection without taking a lock on the entire table.
Is that something particular that Postgres does, or?
Yes.
Yes.
Perfect. Okay, so let's move on to observability. Who would like to go at defining that?
So let's see, observability. Well, you can see which jobs are running in which queues. That's highly observable. The fact that jobs aren't pruned, they stick around after they've been ran, and you can use that to query and find out what's occurring in that. It's extremely observable.
Yeah, and that's the database side. That's pretty much what we mean by observable.
Yeah.
And that's because you took the conscious decision of keeping the records around in Postgres and having as much data as possible in that job table. Yeah,
that kind of came from the inspiration there is streams, originally like Kafka style streams, but then more through the lens of the way that Redis added streams, where you have a stream of events and different consumers can pull them and process them and then acknowledge them, but they're not deleted, or I guess it's called compacted. They're not compacted right away. So you can see information about what happened after it happened. And that's where the idea came from for that part of observability.
And is there anything you utilize for observability from Elixir and the Beam in general?
We use and practically abuse telemetry. I think that's fair to say.
So that's the telemetry package. That's a standard package that a lot of different libraries use. It was new-ish at the time Oban was created and wasn't as widely used, but we use it to instrument everything. So
inspect.
Yeah.
And why do we need this observability in general?
I guess so that you can diagnose what's going wrong or what's going right in your system.
Yeah, you might need to do some business presentations on how many jobs you're running and all that type of stuff.
So Shannon said that we practically abuse telemetry, and that's kind of a reference to things that we've built on top of telemetry in Oban Pro. So there are features there like batch processing or what we call relay, which is like distributed tasks. Those things use telemetry to transparently hook onto what Oban's already doing and build on it without modifying any part of the open source package. Okay. So that's like beyond just instrumentation or debugging level of observability, but actually hooking in and building something else onto it.
Right.
In telemetry, if I recall, in Elixir, you can sort of subscribe to those events as well. So you know what's going on that way. Okay. I think we've done a good job of pulling apart your strapline, seeing how it all works together.
Yeah.
We deserved it.
So for the last part of the show, I'd like to explore what Postgres brings. And you mentioned Oban can work with SQLite, explore some of the trade-offs between selecting two or, if they work together nicely. So first of all, why did you pick PostgreSQL?
Well, it's one of the most widely used databases in the world.
I think everybody should, as far as just default SQL database choices, it's, I think, a go-to for many applications. And especially in the Elixir community, there's major hesitancy around using additional tools for distributed things or caching. So things like Redis it's used, but it's not a popular choice. But almost any application is going to have a database, and Postgres is by far the favorite tool for Elixir applications, much more than MySQL, or I guess that's about the only other practical option, much more than that. So that's kind of the why Postgres part of it. And it does have other great properties that make it easy to build something that has batteries included out of the box. Like it does have that skip locked, and it does have the pub sub stuff built in, and it does have great JSON support. So there's a lot of good bits to it that make it an appealing choice.
And can you just take us through again how you use it with Oban? Just a refresher. So for example, the job gets inserted, the leaders check that row, etc.
Yeah. So aside from leadership, which we talked about before for coordination, there's a table that holds all the jobs. Every row in that table, which is called the Oban jobs table, is a job. And that has a state on it that we track, and attempt numbers and other metadata about when things were inserted or not inserted, and queues, which we have sort of an overloaded notion of a queue. A queue is both the name of something to group jobs and the name of a process that autonomously fetches those jobs. But queues then fetch rows from that match the name of its queue. So like there's a default queue by default, but a lot of people would have, say, exports or something else. And so it runs queries on the jobs table to pull these rows out, do some processing on them, and then check them back in with some other state.
And if I recall correctly, a job can have arguments as well. So variable pieces of data you can give it. So
yeah.
Mm-hmm.
Yeah, jobs typically have args. There's another freeform field called meta that we use internally to add other attributes, like to indicate that something is from a CRON entry or indicate something was snoozed multiple times, which is sort of like scheduling it to process a few seconds later. There's a lot of other rich data that gets written for each job row.
Yeah, I use the job args as basically as possible. I think we insert a job with a customer ID, which is an ID on the Postgres table. So then the job is self-contained. It can just go and fetch the customer details, and to keep the logs light and all the visible things and the privacy things. It's just a UID as an ID, so you can't really see anything in the logs if it ever got out. Yeah, you can put anything you want in there, can't you?
You could, but I mean, aside from the fact that it's just going to take up space on disk, that's probably redundant. There's sort of a freshness aspect to it. So if you put an ID in like you do, and something changes by the time that job runs, like maybe it's got some retries to it, and you fixed something in the row or whatever the reference data was, and that fixes a bug, then if you had put the entire data structure in there, that job would never succeed. Whereas maybe because you fixed it, after it's retried 5 or 6 times, now the data is updated. When it fetches the fixed data, it will run. Which is to say, just try to keep the args as minimal as possible.
Yeah, that's what I do. It's one simple ID. The job itself is defined as it calls other functions within Elixir. So if I've made a mistake and my code is broken, I haven't put all that logic in the standalone job that I've defined, the worker, sorry. So if it does break and there's an error there, I can go back and fix the code, do a hot reload or a restart, and the job just works. So you've got to bear those things in mind, I think, when you're designing your workers. Try and keep them as generic as possible. Well, in my use case anyway. So I do recall that you can use SQLite for this. What are the trade-offs and the different use cases for choosing one or the other or both?
Well, you need something for persistence, and it's natural for small, isolated environments. It's good for engine abstraction. Having another engine is great. Having one that isn't Postgres, and it keeps us honest. There's a term that Parker uses here that I refrain from using. I will let him say it. I don't know why I dislike saying it. You're going to say the monkey term.
Oh, the monkey patching thing. Yeah.
So I feel it keeps us honest. He refers to monkey patching when we discuss it.
So when we say it keeps us honest, so we have the Postgres engine, and then Pro has its own separate engine, which we call the Smart engine, which has more advanced functionality like global concurrency across all nodes, rate limiting.
It's a clean way to do that.
Automatic batching, things like that. And because we have some abstraction around what that is, what that engine is, we wanted to have at least two in Oban itself so that we could run tests on both. And a lot of people asked for SQLite for embedded systems, small environments like people running nerves. Well, yeah, tiny little devices. And by having two of them, we know that all those abstractions work cleanly, and we don't have to maintain some separate test suite and a separate package. But it also sort of proves out that we're not relying on queries or things that only work in Postgres, so that if somebody did want to build it for MySQL or some other type of database, that it would work.
Yeah, it's a good way to keep the abstractions there to make sure you're not just tied into one database. Are there minimum versions you have to run Oban with for Postgres?
I think we're at 12.
Yeah.
Are we on 12?
Yeah, it's on 12. That's somewhat of recent. We documented that 12 was required over a year ago, but we actually used a feature from 12 within the past couple of weeks for a consistency fix. So now it's 12, but 12 is over 5 years old, so it doesn't feel too aggressive.
It did feel like a big jump. I think we supported back to 10 until a few weeks ago.
Yes.
Yeah, I think the JSON support has been there maybe since version 9 or something, which is ancient. But yeah, we're on 16 now, aren't we, I think?
Yeah. The original version that we supported was 9.6 because that's what added skip locked.
And we don't support mature versions of Erlang or Elixir either, so we're not picking on anyone.
Nice. Did you get, just touching back a bit on the history, was there a situation along the timeline where you maybe thought Postgres wasn't the right thing to use, or you saw something else, you had to rethink that selection, or was it a beautiful, happy path the whole way?
We have wish lists.
Yeah.
Within Postgres, for sure. Handling bloat.
Yeah, a much better way to manage bloat in Postgres would be great. That's the biggest thing on the wish list.
I think
so. When we say bloat, we mean dead rows. Rows that aren't actively used, but that the database hasn't managed to clean up yet, which is just an artifact of the way that Postgres' concurrency controls are done. An update to any particular field just marks that row and as an old row and creates a duplicate. Most of the time, this isn't a problem, but I wish it was better. But considering what it would take to do an equivalent set of features, and I can't. I don't even know another language that would let us build things like workflows and chains and batches and all the other stuff in Pro or global rate limiting in some other technology. So while we might have a wish list, it's like...
Still very pleased.
Doesn't the way Postgres do things, it has that background job that vacuums things when the rows are gone?
It does, yeah.
Compacts them, but you have to re-import fresh data to not use the storage. Is that right?
Yeah. So two things that are very relevant here. In Pro 1.3, which is a month or two old now, we added partitioning. And so partitioning is a feature of Postgres that lets you have like inheritance in tables, and you can split it based on some term. So, for example, splitting by job state, which can help with query performance, because if you're running a lot of jobs and you've got millions and millions of jobs and, say, a completed state, you can query a relatively empty available table And that's just much faster. But the other really great benefit there is that it's almost instantaneous to delete the table. So the auto vacuum doesn't have to do as much work. And when you want to go through and delete all the jobs from, say, last week, it just drops the table instantaneously, and there's no actual CPU load, and the bloat just kind of goes away, which is pretty fantastic.
I think we should probably touch on the nice way you've designed this open source product. Like everything I use is in the free version, but if we've got bigger or more complex as users, we have the ability to contact you for support and then look at what Pro brings. And I think all we need to do is change how we pull in the package. It's nothing more than that and some configuration. So it's a good way if we put our sustainability hat on of how open source projects can be sustainable. So it's a good model. Not to make it into too much of a pitch, but
no, thanks.
Thank you.
So
that's
too.
wonderful.
So I think we've got a bit of time to cover some other shows people might like to listen to in support of this. I did one on software telemetry, episode 455 with Jamie Risedale. We did one on data observability with Kevin Hu, if I've said that correctly, episode 507. And we had the big guns on. We had Jose Valim on episode 588. That was a real nice show, speaking to him about that. All things to do with Elixir. So if you want to get up to speed, have a go with that. We did episode 511 with Ant Wilson on Supabase, so Postgres as a service. And a really, really enjoyable one on Postgres performance, if you guys haven't heard it, episode 583 with Lucas Fittel, I think it is. And then another one on job processing is Maxim Fativ on durable execution with temporal. So that was jobs that might last 2 years, and it was quite an immense show. So that's another good one to listen to. Okay, so we've got a bit of time for 2 quick questions before we start wrapping up. Could you provide some tips for any ongoing projects on where to fit Oban in? So they've reached a point, or there's something that just screams, why haven't you got Oban in there?
This is something that I see most of the people that come and talk to us in our very active Slack channel or on the Elixir forum, they're already using Oban. So I think the primary place that we encounter people who aren't using it yet are just
within the forum.
Yeah, we'll see people, and even people in the forum are like, I don't actively use it, but you might want to look at this for this thing that you're doing. And I think it's just people who aren't familiar with the paradigm of background job processors. They're kind of newer to programming or newer to web development, or they just haven't had to manage things at a scale where it's not okay to block and have somebody wait on something to come in. So I think there's just a natural jump from you're learning Elixir, you're learning about the things that it provides like tasks, and then now you've got a task that does something async and it lasts 5 minutes. Well, how do you make sure that when your system restarts in the middle of that 5-minute processing that you're not just going to lose whatever you were doing? That's where the persistent queue kind of comes in. And I think it's more of a matter of educating about persistent queues in general and how beneficial that is. And then hopefully that naturally leads to Oban as a good choice in the Elixir ecosystem.
Yeah, it certainly changed my life with production software. I only recently came across this type of model because I didn't really have anything that needed it. But when you have your own experience sat in front of a browser and you're like, this feels too long, And then you go, oh, there's this a whole way to do things, and it completely blows your mind of how you should be doing stuff. But maybe that's a weakness on my part. But
no, that's exactly the kind of quote we'd like to hear, which is, it changed my life. That's fantastic.
Yeah, I'm just like, put it as a job and a worker and forget about it. It's done. It's great. It takes a little bit longer, when you break up all the different steps, but it fits nicely once you get your head around it. My last question, what's the most common issue you see when users are trying to, I'm going to say adopt Oban, but maybe just use Oban or a job processing framework? What do they not get that takes them a wee while?
I would think the naming of the queues, the typo in the queue name and naming the queues.
It's almost funny. I think it's...
No, I don't mean that to make slight of somebody, but that comes up so often. I would say checking what version of Oban you're using and whether or not you've named your queues or if there's a typo in the queue name is first and foremost the biggest support issues we encounter.
Yeah, I think we had done like a napkin calculation, and I think 80% of the issues people initially came to us with were, why aren't my jobs running? It's, well, you put it in a queue that had it was like your own special queue name, but you never started a queue with that name. So there's nothing to run.
There's nothing to run.
Yeah.
Yeah, because the queue's run by a process, isn't it? To check the database and all that type of stuff.
Yeah. And part of the reason there is that you want a certain amount of concurrency for different types of work. So you could put everything into a single queue and say you're only allowed to do 10 concurrent jobs, but then you'll end up with things that process really quickly and some others that are really slow. So if you're processing uploaded images, that might be kind of slow, and then that's going to block things that you want to be very quick, like sending a push notification. So you naturally end up modeling it where you have different types of work in different types of queues, and they have their own concurrency. And getting into that mindset, I think there's a stumbling point between, oh, I want to put this in a different queue, and, oh, I need to actually start that as its own separate queue.
Yeah, that's something I need to look at because I don't have any named queues apart from out of the box. I think there's 10 workers or something.
They're all default.
Yeah.
Yeah.
The default is default.
Yeah, so my scenario there would be I can't imagine 10 people sat in front of this application clicking create, But then just as you're speaking there, I'm thinking, well, I'm cascading these jobs, daisy chaining them. And if they run really quickly, they might be trying to insert jobs into the next queue, and that fills up that small list. So I haven't had any emails from AppSignal telling me, because they've got a really nice out-of-the-box Oban monitoring queue system. I don't know if you've seen that.
We have. That was a fun surprise because they didn't reach out or anything. They just kind of built it.
Yeah, it's really nice. You just get alerts on the jobs. You can see the arguments. And so I've not had any triggers and I've not had any complaints. So I presume it's all right.
I would just like to mention anybody who is having an issue where their jobs aren't running, we appreciate when you reach out. We look forward to building that trust within the community. If you have an issue, we are available. We're here.
Much appreciated. Okay, so let's wrap up. It's time for my usual question that I like to ask guests. If there was one thing that you'd like a software engineer to remember from this show, Shannon, what would you like that to be? And then on to you, Parker, after.
Well, an updated version of Oban. It provides improved functionality. So I would ask that you keep your version of Oban current.
Okay, nice one. Parker?
Shannon kind of covered both of them. Stay up to date. It doesn't languish. We release updates and fixes all the time. Try to keep the issue tracker really clean. So if you have any problems, let us know. We're eager to fix things and make sure it's just a good, clean, simple experience for everybody who wants to come use it.
Yeah, you've been very responsive whenever I've opened an issue, which I think was maybe once. And then I just do the simple depend a bot through GitHub that looks at my Elixir list of dependencies. And
that's highly recommended too.
Yeah, I'll get a pull request on a Monday morning to update Oban and it shows the change log. And I just click merge and off we go, redeploy. Is there anything we missed that's key to this whole discussion and that we've made assumptions on that you can think of, or are we good?
I know you've done episodes on Elixir before, and I would imagine a lot of your listenership is familiar with Elixir and what it is. But I have to say that the whole project would be maybe not impossible, but extremely difficult with any other runtime. So I'd encourage people who are kind of curious about what the language brings and what the runtime offers to really check it out. It unlocks things that are immensely difficult to do, if not impossible, in other situations.
And people can follow your company, Soren, on Twitter, but what other ways can they get in touch?
You can follow us on Twitter. We're not especially active. It's mostly just kind of announcements about things. Primarily Slack and the forum are the best ways to get in touch.
And that's your own Oban Slack?
No, it's the Elixir community Slack, which is a pretty bustling, thriving Slack, but there's an Oban channel in there.
Okay, yeah, there's loads of good things in that. I'm on that as well. Okay, Parker and Shannon, thank you for coming on the show. It's been a real pleasure. This is Gavin Henry for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.